Hello, I am David W. Parker, and this is Programming Today I Learned Algorithms. This is episode 6, and we'll be looking at quicksort. So it's kind of like merge sort in that it uses the divide and conquer paradigm, and we get to change our array in place, so that's kind of nice. So we divide our array, which if P is the lowest value and R is the top, two subarrays, such that each element in one is less than Q, and the other one is everything is greater than the Q. And then compute Q as part of this indexing. Then we're going to conquer. We're going to solve each of those subarrays recursively, so calling quicksort again on each of those. And then we're going to combine it all together, but it's already sorted, so we don't have to do any work here. So we have, here's the quicksort algorithm. We're going to find out what that partition is, and then we're going to have everything below the partition here, everything above the partition there, and we'll output it. So partition is where all the magic happens. So as a quick rundown, here's the array that we're using, and I've already run just partition, commented this out, and the output of what a single partition looks like. So 4 is going to be our pivot point, so everything's going to be pivoting to either side of 4. So what we're going to do first in partition is we're going to compare 2 to 4 and place it on the left or right. So that'll be on the left hand side. Then we'll compare 8 to the 4, and that's going to be on the right hand side. 7, that'll be on the right hand side. Then the 1, and then that'll be on the left hand side. Then the 3, that'll be on the left hand side. And then the 5, which will be on the right, and the 6 on the 4. And then afterward, all we do is swap out the index, the pivot value, excuse me, to the position that it needs to be in around the rest of the sorted array. In this case, I'll be find the 8 here, and it'll swap out with the 8. So this is what a single instance of what the partition would do. And then at which point we will have two subarrays, each of which we will iterate through and sort this side for one, and then this side for the other, and the 4 is already sorted. So that's kind of how the whole thing works, and then here's just the whole thing ran. I commented out the other stuff. You can add comments in if you'd like to see it in console logs. So let's just walk through what the actual partition code looks like now that I've explained a single time of how it goes. So here's the pivot point as shown before. Here is the starting element. And what we're going to do is we're going to swap each of the elements from the lowest, lower than the pivot, until all of the elements have been moved to either side. So this is really where all of the magic happens. And if it's less than the pivot, we're going to go ahead and swap it out. Otherwise, we'll leave it in place. And then we'll ultimately swap out the pivot one position. So this is going to take O of n operations due to the for loop. And then the quicksort algorithm itself is best and average case, it's going to be n log n. Worst case, if it's already sorted, it's going to be O of n squared, because what ends up happening is if it's already sorted, you're going to have every single element in one side of the binary tree for this. So this is going to be, every element's going to be on one side and 0 elements are going to be on the other, and it's going to end up running the same thing n times. So n times n is n squared. I'm not going to go into the maths behind it, but in CLRS, it's proven that if any single element is on the other side of the binary tree, then you will hit the average case scenario of n log n. So even if it's 99 elements on one side and 1 element on the other, you're going to end up hitting n log n. So it's pretty nice in that regard. So it's still a really good algorithm that you should know and be aware of. This partition method, by the way, is the Lomuto partition scheme. I didn't cover the Hore partition scheme, which uses a double while loop. You can look at each of those variants online. I believe Jason Park's algorithm website uses the Hore partition scheme, so you can see how he did that with the double while loop. Anyway, that's it for today. I hope you liked what you saw. Please subscribe. Thank you.